Hello, my name is Steven. Welcome to Highfinder Tech Talks, where we understand the technology that makes the hydrogen economy work. Today, we are going to take an interesting perspective at a bigger topic, which has been discussed a bit, and we hope to contribute in an interesting way to that. For that, I have a chemist, a really renowned scientist, joining me all the way from Canada. It's Sean McKinnon from Loop Energy. And we're going to be talking about fuel cell or battery electric truck and environmental perspectives. Sean, it is a pleasure to have you.
Thank you for the invite, and it's a pleasure to be here myself as well. Thank you.
Yes, so Sean, I think we have a bit of ground to cover. So just to even understand this perspective, where do we start?
Well, we can start by a number of different ways. Historically, when you look at batteries versus fuel cells, you can do comparisons with total cost of ownership. You can look at range of the vehicle, the use cases in plug and play, the various fueling infrastructures that are there or that are not there that drive that conversation. And one of the recent ones that people have been focusing on is the gross vehicle weight and the available payload that can be delivered. The focus for today, though, I'd like to try and take a slightly different perspective. And it's kind of focused on the why. Our focus today here is to really look at the environmental benefits of running these vehicles, electrification of heavy duty. So let's unpack that today if we can.
Yes. Okay. So yeah, obviously we know that they are contributing to a significant part to the carbonization, or so if we want to talk about decarbonization, we look at that. How do you approach this?
Well, we can approach this in a number of different ways, but the first one that we're going to look at is kind of the problem that we have in the heavy duty sector is it's a very small number of vehicles that are licensed in the fleet. 4 to 5% in the world are heavy duty. Mind you, they make up about 25% of the total transportation emissions in the sector. The goal we have is if you look at that 4 or 5, we can quickly take out a lot of the emission profile of our transportation sector, but we need to go quickly. And so the goal here is how do we go from CO2 emitting technologies that we use today to move our goods around to that of a zero emission tailpipe application. So historically, when we look at the conversation between batteries and fuel cells, we've been focused for many years on the comparisons of passenger cars. Most of us drive passenger cars. Most of us drive cars to work. And so that's our perspective. And when you look at, there are a lot of numbers here on the side here, and you can take a look at those at a later time. But when you look at the perspective, cars, direct electrification is the most efficient use of our energy by far. This has been the perspective for a number of years, and it's a standard perspective. So if we look at 100% renewable energy coming in, we can either directly electrify that through battery vehicles and come out with 77 to 81% efficiency from renewable to wheels, or we look at hydrogen fuel cells, and because we need to convert that renewable energy to hydrogen first and then run that back through a fuel cell, then yes, we're in that 33 to 42% range of efficiency. And this has kind of driven the perspective of, well, which one is better, battery versus fuel cell? And this is the one that we need to unpack a little bit more, because there's more to it than just the use of renewable energy.
Yeah. Okay. So just if I'm looking at this diagram, if you can show that again, on the left side, we see essentially the output of a renewable, so say solar facility. Is this the photons? Let me see, the energy in the photons coming in, or what is this? And then the percentage of energy that is, let me say, utilized down to the wheels. So at the bottom, the 77% will be what is reaching the wheels from the photons from space.
That's pretty much it, yes. And so when we look at comparing that to hydrogen, and the current perspective is battery electric cars will always be 2 times more efficient than a fuel cell electric car in utilizing renewable energies to wheels.
Yeah.
And I don't contest that. That's just the math. That's just the way it works. We have to make hydrogen. It's not 100% efficient. We have to run that through a fuel cell. It's not 100% efficient. So yeah, we are going to have our losses.
Yeah.
And in this case, we're about 2 to 1 versus battery electric vehicles.
Understood. All right. So, okay,
Now,
given this, yes, please go on.
Yeah, this is where it gets interesting. Heavy duty trucks are not passenger vehicles. They are a very different use case. So in this case, a diesel truck is getting, for the metric folks out there, 47 liters per 100 kilometers. It's a lot of fuel that you're going through. That's 5 miles per gallon. For these vehicles to go 800 kilometers or 500,000 or 500 miles, they're going to consume quite a bit of fuel. And if you look at a use case where we're looking at, in the ballpark of 100,000 kilometers to 60,000 miles a year for these vehicles, they're going to go through appreciable amounts of fuel that are going to result in about 122 megatons of CO2 per truck being released. And when we look at how that compares across the board from a vehicle to a truck, in the previous slide, you would have seen that a vehicle only needs about 0.25 kilowatt hours per mile. In trucks, you're looking at 2 kilowatt hours per mile in general. Recently, there's been some projections that they're able to achieve maybe 1.7 kilowatt hours per mile. And there have been some future projections that 1.5 kilowatt hours per mile is potentially attainable. So I've used 1.5 here as just a general, as the working kilowatt hours per mile to do this assessment with. Yes. And when you look at how you size battery packs for vehicles, you have a certain amount you need to run the motor, you need a certain amount for range. And for a healthy pack, you don't really want to discharge it too much past 50% of that total available capacity in that pack. And so when you do the math on that, it turns out that a battery electric truck to replace that diesel vehicle is going to need a pack of about 1,500 kilowatt hours in size. And that's a big pack.
Yes. Wow, that's a big pack. I mean, okay, I have no bigger knowledge of these things, but probably that's also going to be a big battery in itself to fit into the vehicle.
Yes, and the 1,500 it lends us to some easy math right now. We look at about 150 watt hours per kilogram right now in a battery pack. That's kind of a going number that's in the industry. So this pack right now, if you do the math on that, that's a 10,000 kilogram pack.
10,000 kilograms, that's 10 ton.
15 kilowatt hours would be 10,000 pounds or 10,000 kilos. I'm sorry.
Wow.
So when you make that comparison, sure, hydrogen's the lightest element we have. That's a very easy comparison to make. We can give you quite a bit of energy for only 40 kilograms, but that's not the focus that I wanted to work on today. The focus here is how do we abate CO2 in the fastest possible way we can with these battery packs that we're currently using. So let's look at our energy. We spoke about this a little bit earlier, Stephen. Yes. We talked about solar energy coming from renewable energies and working down through a battery pack or going to electrolysis and into a fuel cell being 2 times more efficient. And because that has kind of driven the perspective, I'd like to kind of switch the conversation a little bit here. So let's kind of run through this train of thought. So in the bottom left corner here, we have an abundance of solar energy. According to the US DOE, we've got 173,000 terawatts of energy continuously striking the earth. We're in no shortage of solar energy. Yes. We may be in a shortage of harvesting solar energy, but the availability and the abundance of that energy is going to be with us for as long as we're on the planet. So if you move forward and you say, well, what's the goal of emission reduction? The goal is really, let's get CO2 abated out of the transportation sector as quickly as possible. And if we take the current perspective, maybe the most logical path is to deploy battery solutions as fast as we possibly can to help electrify the heavy-duty trucking industry. But now it lends ourselves to an interesting question. Compared to solar, lithium ion battery resources are absolutely constrained because they don't hit the planet with the same level of abundance that solar energy does. And I understand that's a simple way of looking at it. But at the same time, it does lend itself to the question, should we be using our batteries in the most efficient way that we possibly can? And it is about efficiency, and that's the kind of the nutshell of the problem that I'd like to try and unpack today.
Understood, understood. When we are talking about efficiency, I mean, you as a chemist, I know that you guys, when you're calculating your reactions, you also say, okay, what do we have abundant of? Okay, we don't care so much about that. Let's try and optimize for what we have the least of and get it to work around that. So you're saying we have abundant sunshine. So, okay, then we just take that for granted and let's see along the chain now, where are the other things where we have serious constraints that we need to look at that we can optimize? This is correct?
That's essentially the view, yes.
Yes. Okay. Wow. Okay. That is super interesting. What does this then lead to in terms of conclusions?
Yeah. So if we start looking at that comparison of battery versus fuel cell, we're going to throw another column in here, and we're going to call it a fuel cell range extender. Mm-hmm. Range extenders have they found a niche in a few different applications, but in general, what a range extender is, it's a smaller battery with a power source and a generator on the vehicle. So in this case, it's a fuel cell driven or a fuel cell powered by hydrogen range extender. So when your battery pack gets to a certain depth of discharge, you can turn the fuel cell on, recharge the battery in situ while it's on the road, driving around doing work, and you can bring that battery back to the same state of charge that you need it to be at in order to keep doing the work that you're trying to do.
Understood.
Right?
So it's basically riding along with the vehicle, charging the battery as we go.
Yeah, I've said this a number of times, and it's not a very pretty way to say it, but we're essentially a glorified extension cord, right? If you can bring the extension cord with you, you'd never run out of energy. But if you can keep your hydrogen fuel cell, if you can keep your hydrogen tanks full of hydrogen, technically that's your extension cord.
Yeah, the extension cord would be the 100% solution if you were talking now from renewable source to the, yeah, exactly. Interesting. Please. Okay. So yeah, range extenders. We got that?
Yes. Sorry, go ahead.
Yes, please.
So what's really interesting about this is that, on the left-hand side here, you can see that we've got a 1,500 kilowatt hour battery pack, which we unpacked a little bit earlier. But in a range extender, we can do it with a 150 kilowatt hour pack, not 150 kilowatt hour or a 1,500 kilowatt hour pack.
Okay. No, fine. It's fine.
So we only need 1/10 of the battery pack per vehicle. And that is the essence of the analogy that I'm going to provide here.
Okay, understood. So that means that we need a much smaller battery for the same type of vehicle.
That's it.
Yeah.
Okay. So same efficiencies, it's the same work being done. It's the same range being done, but we're going to do it with a 150 kilowatt hour pack and 40 kilograms of hydrogen instead of a 1,500 kilowatt hour battery pack.
Understood.
What does that mean? Well, if we're 1/10 of the size of the pack, then we can take that exact same 1,500 kilowatt hour battery pack and we can distribute it across 10 trucks. So this is the interesting piece that we need to understand from a heavy duty perspective. It's not a car.
Okay, so understood. That means essentially the same battery which you would have used to run a purely battery electric vehicle, you could now split into 10, and with that, essentially have 10 emission-free vehicles on the road.
That's correct. And that is essentially a 10 times faster CO2 abatement for the same amount of lithium ion battery resources.
Okay, I must ask then, so in the fuel cell system or in the range extender, are there also any rare types of resources that are needed to run those?
Of course, and that's why I'm saying I'm providing a simple view, but it's not an in-depth view of all the metals used by both applications. The nice thing about platinum, ruthenium, and the number of elements that we currently use in the fuel cell space, a lot of those are already in catalytic converters today. So some of the material sets that we need can actually come from old vehicles. They don't necessarily have to come from the ground.
Okay, so that means essentially a truck running today with a catalytic converter already has more or less the same or a similar quantity of rare minerals which it would have in a fuel cell system.
That's our understanding. I think the numbers are something around 7 to 10 grams of precious metals in a vehicle catalytic converter, and you're in the 35 to 45 grams when you're looking at trucks due to all the emissions profiles that they need to clean up after. And so that 30 to 40 is kind of in a similar space that we'd like to be in within our units as well.
Okay, so when we're talking, let me say, trying to replace a petrol or a diesel-driven vehicle with another one, you can say, in terms of at least the rare minerals, you would have more or less the same already in there. But the difference now is the lithium ion, which is, of course, tenfold, depending on which comparison you choose now. Yeah.
Yeah. One thing I'll add as well here, which is an interesting perspective, is when it's a range extender, we also don't need a fuel cell engine that's large enough to drive the motor. It only has enough to compensate for the rolling resistance and air drag of the vehicle fully laden down the road going at max speed. And that tends to be around 125 to 145 kilowatts. If we needed to build only a fuel cell without any batteries or just a very small battery, and have a fuel cell dominant a vehicle, you now have to match the fuel cell to the max power of the engine. And now we're going to need about a 300 kilowatt fuel cell.
Okay, so that explains a little bit of the why the range extender model, right?
Correct. The range extender model is, it helps to reduce the amount of battery, but it also helps to reduce the amount of fuel cell materials that are needed as well.
Okay, so then now, taking the environmental perspective again, what is our best option?
Well, with our perspective is a range extender is the best option. And when you do comparisons, I like this graphic because it kind of brings home a little bit of perspective of, what are these emissions worth from a car perspective?
Yes.
We all drive cars. Not a lot of us drive trucks. So our perspective is from a passenger vehicle perspective. So from the range extender model, if you take what we've been describing today as an opportunity, you would look at a 1,500 kilowatt hour battery pack. And when you divide that into 10, you get 10 vehicles as opposed to one. This one vehicle will abate 122 megatons of CO2 per year.
Yes.
Which is a decent amount.
Yes.
However, the 10 trucks will get rid of 10 times that value. We'll get rid of 1,220 megatons of CO2 per year. And to put that in perspective, one diesel vehicle puts out the emission equivalent of about 34 vehicles, 34 cars. And so in our perspective, that one battery pack might have an opportunity when deployed through a range extender model to remove 340 passenger cars worth of CO2 emissions per one battery pack. And that's why we think it's more efficient in the end. If our goal here is to abate CO2, why are we putting electrification solutions into trucks? It's because 4.5% or 4 to 5% of the fleet accommodates for a quarter of the emissions. So let's go get rid of those emissions as quickly as we can.
Understood. Wow, that's some very interesting numbers that have come up there. So if we use the same battery pack, which we would require to replace one diesel truck, to instead implement that in vehicles with range extenders, fuel cell range extenders, then we could replace 340, or let me see, the emissions equivalent of 340 passenger vehicles. That is quite a number.
And so when you look at the car perspective, one battery vehicle versus one passenger car, those one-for-one replacements, they make sense. the use case makes sense. A lot of us only drive, less than 50 kilometers a day back and forth from work. So the battery can be recharged at night. It's not an issue. Doing that with a truck that's doing work all day is a very difficult thing to do. And so when we look at trying to make that the largest impact we can in the shortest period of time, using the resources that we have that are not abundant to us, that we need to use them diligently and use them in the most efficient way possible. When it comes down to the question, battery or fuel cell, environmentally speaking, which is the best option for electric truck? Our perspective is the answer is yes.
Is yes.
It's not battery or fuel cell. It's both.
It's both.
It's a smaller version of a battery pack and it's a smaller version of a fuel cell, so that both, when working synergistically together, is a more efficient use of our resources, and it's the fastest way that we can get CO2 out of the atmosphere.
Understood. So essentially, smaller battery pack with smaller fuel cell system is the fastest way.
It is.
From an environmental perspective.
There are other knock-on effects that we can unpack later on, because there's a whole series of other benefits that come with that.
Yes.
But at the end of the day, it truly is not a discussion, battery or fuel cell. That's a car discussion. It's not a heavy duty discussion.
Yeah.
When you look at heavy duty, it's both, and they both have to work together.
Well, I think the good news is that there is technology available to already go this way. If we're looking at something that's impossible, then that's a different thing. But now we see from this math that you could optimize that tenfold from a rare mineral perspective. That's something. Thank you for sharing that, Sean.
It's a very, and I understand it's a very simple view.
Yes. But
sometimes it's simple to understand the gravity of the situation that we're in, and a lot of times, keeping it simple can be the easiest solution. So in this case, it just doesn't make sense to put one battery pack into one diesel truck and try and abate the emissions from one truck if we have an opportunity to do 10 times that value. 1, 2 times, sure. 2 times, 3 times, sure. 10 times, that's an order of magnitude, and it can't be ignored. Figure out if there's a way that we do this a little bit quicker.
Yeah, I found your pictures interesting, where you showed one truck is that many equivalent trucks and vehicles. There you go. See, okay, so that means actually converting or using the range extension model will help one vehicle to replace 340 the emissions of 340 passenger vehicles. Sean, unfortunately, we have already run out of time. But the good news is that we have managed to, walk this perspective together with you. Thank you so much for sharing it. Yes, as you said at the outset, there are several perspectives to take. Nevertheless, I found this particularly interesting when you say let's focus on what we don't have abundance of, what we really need to mize on. And I think this is something that should be considered, in my view. And hopefully we can take some motivation for this to start, to continue solving our decarbonization challenge that we have.
It's 4 to 5% of the vehicles. It's low-hanging fruit. Let's go get it.
Let's go get it. That's a nice statement. Thank you very much, Sean. And thank you very much for all who have watched the video. I hope you have enjoyed this as much as I have. If you want to understand fuel cell systems or know where to get them or get in contact with people like Sean, please go on highfinder.com, where you'll see many of these kind of systems and other things that will help solve technical problems in the hydrogen economy, all the components and so on that you need. Please visit highfinder.com. Subscribe to this channel, give us some kudos on LinkedIn or here or anywhere. And feel free to reach out to Sean and any of his colleagues at Loop. They are also very friendly, as I know them, and will answer any questions. Thank you again for watching. Thank you, Sean, for taking the time. This has been really good. And I wish you all the best. And hopefully see you in another video sometime. Thank you.
Anytime.
Goodbye.
Best of luck.
Bye.
Bye for now.